Hey, what's going on? We're looking at synthetic division of polynomials. It's another form of dividing polynomials. All right, another method. Hope this video helps. Let's dig in. All right, synthetic division is a shorthand method of dividing a polynomial by a linear binomial and using only the coefficients. For synthetic division to work, the polynomial must be written in standard form. Standard form meaning descending order. Alright, so you want your exponents to be written like x cubed, x squared, x, then your constant. Alright, whatever your constant is, okay? Using zeros. Now, you use zeros as a coefficient for any missing term. Alright, and the divisor must be in the form x minus a, Alright, so here's an example right here from our textbook. But I'm going to go ahead and explain, man. Let's go ahead and just do an example. The first thing you need to know is this. This is our binomial we're dividing by. Alright, so we're going to write that over here. Where we take that x minus 1, set it equal to 0, and solve it, you get x is 1. So x is now 1. Then I'm going to write now all the coefficients of this polynomial right here that's present. Alright, all of these coefficients. So right here the coefficient is 1. Right here the coefficient is 2. Right here the coefficient is -5. Here's 3. And here's -1. Now the thing I want to point out, man, is this is standard form. This is 4, 3, 2. That's x to the first. And that's the constant, x to the 0. So this is standard form. So now all you do is this. Take your first term. Bring it down. You always bring your first term down. And now I'm going to multiply these two. So I go 1 times 1 is 1. And I write it over here underneath the next term, the next coefficient. So then, since this is positive, I go 2 plus 1 is 3. Now I'm going to take this 3 and multiply it by 1. 3 times this 1 up here. Alright, so 3 times 1 is 3. So it's positive. So -5 plus 3 is going to be -2. Now I take this -2 and multiply it right here to this 1. This 1 right here. So -2 times 1 is -2. So I have 3 minus 2. This is negative. 3 minus 2 is 1. Then I take this 1 and multiply it up here to that 1. 1 times 1 is 1. So now I have -1 plus 1 because it's positive equals 0. Alright. Now, I put this box right here so you know this is your remainder. Well, 0 is a remainder, so there's nothing to write in that regard. But I want to show you what these coefficients are now. All these are actually coefficients. Alright, and what we do with them is this. We're going to, well, let's see. See how this right here is the 4th degree? Oops. Didn't mean to do that. See how this is the 4th degree? Well, when we write our new answer with all these coefficients right here, we go down a degree. Alright, we decrease by 1 degree. Alright, so see how this is 1x to the 4th? Well, this right here is going to be 1x cubed. And then we just keep going in descending order. So this will be positive 3x squared. And then this is -2, so -2x. Alright, 3, 2, 1. And then there's my constant. Alright, plus 1. So again, this started with the 4th, so here I'm going to start cubed. If this was cubed, I would start squared. If this was to the 8th, I would start with the 7th, okay? And just go in descending order. Alright, 3, 2, 1. Then my constant, okay? Here's another example right here. Let's see here. X plus 2. So we take x plus 2, set it equals 0 and solve it. You get x equals -2. That's going to be in this box here. Now I write out my coefficients. Notice that this is -1, -1x to the 4th. Now this one, look, this was 4 then 2. So this is in standard form, but it's missing a term x cubed. Alright, so we're just going to put 0 in place of x cubed since it's not there. Alright, just put 0 in this place. So now we have -1, 0, then 4. Again, I put the 0 because x cubed isn't there. So 4x squared plus 5x plus 5. Alright. Now, to get started, we'll go again. Take your first term, bring it down. Always bring your first term straight down. Alright. So now -1 times -2 is going to be +2. And 0 plus 2 is 2. Then 2 times -2 is -4. Well, 4 minus 4 is 0. Then 0 times -2 is 0. 5 plus 0 is 5. And then 5 times -2 is -10. So you have 5 minus 10. Alright, and 5 minus 10 is going to be -5. Alright, this is our remainder right here. Alright, so we write this remainder the exact same way as we did in long division. Notice right here we started with the fourth. So since we started with the fourth, we're going to decrease this degree by 1. So -1 x cubed. Alright, I didn't write the -1 there, I just wrote the negative. -1 x cubed plus 2x squared. This will be a 0x, so I don't have to write the x. Alright, plus 5. Alright, because if I did, it would just be this. Right, and this is why I don't write it, plus 0x. Right, and 0 times x is 0. Alright, so here I'm just going to write it just so you can see it. Plus 5 minus, this is negative, would be -5 divided by our divisor. That's our divisor, x plus 2. Alright, so just to simplify without this 0, here let me write it out so you can see it. -x cubed plus 2x squared plus 5 minus 5 divided by x plus 2. I did not write the 0x this time. Alright, I didn't write it because 0 times x is 0. There's no need to write it, okay? Alright, one example right here that you try. In case you miss it. Alright, we have, this would be 1. And then over here we have 1x cubed minus 1x squared minus 5x and 5. Alright, so your first term, bring it down. 1 times 1 is 1, -1 plus 1 is 0, 0 times 1 is 0, -5 plus 0 is -5, -5 times 1 is -5, and 5 minus 5 is 0, no remainder. So since this is cubed, we're going to go down a degree, so x squared, there's no 0x, so we just go -5, constant. There we go. Now, right here it says you can use synthetic division to evaluate polynomials, which we just did. This process is called synthetic substitution. Again, we want to evaluate a polynomial. That's synthetic substitution. Alright, normally with substitution, you would take a value, plug it in for every x, and then that will be your answer. But in this case, we're going to use synthetic substitution. This process of synthetic substitution is exactly the same as the process of synthetic division. It's the same thing, but the final answer will be interpreted differently. Alright, so the remainder, guys, the final answer right here, that's the remainder. Alright, as described by the remainder theorem. It's the remainder theorem. So right here, it was divided by x minus 3. Well, remember, you said that you go to 0 and solve it, you get 3. So now when you divide it, the remainder theorem tells us it's just what's the remainder, 7. So P of 3 equals 7. Alright, and what happens if you plug 3 right here? You're going to get the 3 right there. 3 cubed is 27. And then 3 squared is 9. And 9 times -7, actually 9 times -4 is -36. And then 5 times 3 is 15. And plus 1. And when you do that, you plug it into your equation, you should get 7. So let's see here. And when you do that, you get 7. Now, let me explain what's actually how to do it with synthetic division. Alright, with synthetic division, I want to show you with this example here. When you take the 2, alright, x is 2, and you do everything the exact same way as synthetic substitution. So you have 2 as your coefficient, 5, -1, and 7. Alright, and you do synthetic substitution. You have 2, you break it down. Alright, 2 times 2 is 4. 5 plus 4 is 9. 9 times 2 is going to be 18. -1 plus 18 is 17. And 17 times 2 is 34. Alright, and 34 plus 7 is 41. Alright, that's your remainder. So P of 2 equals 41. Alright, this is the remainder thing. If you want to check yourself, you could just plug 2 into all of this. Like you could go 2 times 2 cubed plus 5 times 2 squared, minus, backtrack a little bit, 5 times 2 squared minus 2 plus 7. So I'm just going to check it so you can see that's, and 8 times 2 is 16. So let me write that out. And then you have 2 squared is 4. 4 times 5 is going to be 20. And then 20 minus 2 plus 7. So 16 plus 20 is 36. 36 minus 2 is going to be 34. And 34 plus 7 is 41. Alright, so this is a way to check yourself. Alright, this is a way to check yourself. Now I got a U try. Alright, just to work through it. So again, x is -3. So we have the coefficient of 1, 3. Notice that this is 3, 2. There is no 1. So we put 0, then the constant of 4. So now bring down your first term, 1. 1 times -3 is -3. That's 0. 3 minus 3 is 0. 0 times -3 is 0. 0 plus 0 is 0. And 0 times -3 is 0, and 4 plus 0 is 4. So there's your remainder, P of -3. Man, that's not a big 3. Let me erase. So P of -3 equals 4. Again, if you want to check, you can check it. You can go -3 cubed plus 3 times -3 squared plus 4. So -3 cubed is -27. -3 squared is 9. 9 times 3 is going to be 27. And then you have plus 4. But -27 plus 27 is 0. Plus 4 is 4. So just checking myself. Now, for this last example, we got a word problem, but guys, it doesn't change anything. It says write an expression that represents the area of the top face of a rectangular prism where the height is x plus 2 and the volume of the prism is x cubed minus x squared minus 6x. So, just so you know, the volume of this prism, guys, would be area divided by height. Alright, so again, it's just this expression divided by that binomial. Alright, so we do the same thing right here. X is going to be, well, yeah, when we saw that x plus 2 said it was 0, x is -2. So when we take the -2 and we write out the coefficients, we have 3. I'm sorry, that's not right. We gotta write the coefficients. It's late, so I'm sleepy. Alright, the coefficient is 1. The coefficient right here is -1. And the coefficient is -6. Alright. So now we go bring down the first term, 1. 1 times -2 is -2. Well, -1 times -2 is going to be -3. Negative 3 times negative 2 is going to be positive 6. And negative 6 plus 6 is 0. So there's our equation. Remember, this started cubed. So we have x squared, right? 1x squared minus 3x. You go in descending order. Alright. That was 3, so you start with 2 and 1. So there we go. That's v of x right there. I'm sorry. That's actually a of x, the area. So area equals volume divided by height. But alright, that's neither here nor there. This should be a of x. Area equals v over h. Volume over height. So area. So there we go. Alright, I just want to make sure I wrote that out correctly, man. That's your notes, man. And again, I hope these help. Alright. Catch you later.